Here we've got a cannon being fired horizontally off of a 36-meter high cliff, and the cannonball comes out of the muzzle of the cannon at 15 meters per second. Now it wants to hit the enemy boat down below. We know it's going to travel in a parabolic arc, so let's have a look at what that looks like. Since it's fired off flat, it starts at the apex of that parabola, and eventually we want that cannonball to hit the boat. We're trying to figure out how far away should the boat be when they fire the cannon? What should dx be in order for that to have a successful target? So once again, we want to set this question up both horizontally and vertically. So here's my horizontal direction, which I always call the x. And in the x, there's only three variables: dx, vx, and time. And in the y, because we have accelerated motion, we need all five variables: v initial in the y, v final in the y, acceleration, time, displacement in the y. Now we can start populating our list with variables. Vx is 15 meters per second, and that value will remain constant throughout the flight, assuming there's no air resistance. V initial in the y, since we're shooting it off horizontally, is 0. It has no vertical component at this point. There's nothing up or down about that motion. It's completely flat. We don't know the final velocity in the y just before it hits, but we do know ay is negative 9.8 meters per second squared. We don't know the time of flight, but we also know the vertical displacement. And since we're on our way down, I would say my displacement is negative 36 meters. Now we want to find dx. In order to do that, we need time. So we can't do that in the horizontal column just yet. Let's look at the vertical column. If we're going to try and find time, avoid equations with v final in it. So if you look at your formula sheet, the one equation that does not have v final in it is d is vot plus 1/2 acceleration times time squared. And since we have to remain in this column, v initial in the y is 0, 0 times anything is 0, and I get a simpler version. I get d is 1/2 at squared. Now if I want to solve this for time, I can multiply both sides by 2 to get rid of the 1/2. And then divide both sides by a, and then ultimately take a square root. My time will be the square root of 2d over a. When I get my numbers in place, 2 times negative 36 divided by negative 9.8, and when I take the square root of that, I end up getting a time of flight of 2.71 seconds. So let's add that to our list. The time it takes to hit the target, it's in the air for 2.71 seconds. And because time is scalar, it's also horizontally 2.71 seconds. Now the only thing left is to find dx. Fortunately, we only have one equation. Dx is vx times time. Vx is 15, and my time is 2.71 seconds. And when I multiply these two together, I get 40.7 meters for dx.